Hello friends, welcome to lecture number 19. In today's class, we will read about the value of capacitance when a dielectric is introduced into the parallel plate capacitors. Okay, so let's start. So we'll find the capacitance of a parallel plate capacitor after the insertion of the dielectric. So we have got parallel plate capacitor. This blue color is the parallel plate capacitor inside which an dielectric is inserted. The distance between the two plates is D and the area of the plate is A. And you can see I have given some gap here. But in order to explain you, this gap is there, but in reality there is no gap between the dielectric and the parallel plate capacitors. Okay, so we know that the capacitance is given by Q by V. Okay, and what is the total charge here? Surface charge density into the area divided by V. V is nothing but E into D, because we know the relation E is equals to minus dV by dx. So from this we can make out that your V will be equal to E dot D. Okay, so what is the electric field due to the presence of the dielectrics? We already know that the electric field will be reduced by a value K. Okay, in the previous class we have studied. So it will be sigma A, and what will be the electric field? Sigma by epsilon naught. Previously it was there, because of the dielectric it is 1 by K into D. Okay, so sigma gets cancelled out. So what will be left out for you? Epsilon naught K A divided by D, and this is equal to C. So this is the expression for the capacitance. Okay, now I have told you the value of K will range from, in the previous class we know, from will range from 1 to infinity. And what was our first importance of this dielectric? That it increases the capacitance. Due to insertion of the dielectric, it increases the capacitance. So which is very well clear from this, because of the insertion of the dielectric, the K value is in the numerator. That's why we can say the capacitance has increased. So the capacitance has increased by K times. Okay, so the first property is satisfied. Now let us go to the other kind of arrangements. Now suppose you are given with a dielectric, but here the dielectric is not totally filled up. A part of the parallel plate capacitors is filled with dielectric. Okay, the dielectric constant is K here. So this is your dielectric, and the width of the dielectric is T, and this dielectric is kept at a distance x from the positive charge plate, and the total distance between the two plates is your D. Okay, so it is quite obvious, if this is x, this is T, then this portion, what will be this portion then? This one will be your D minus T minus X. Okay, now for this kind of situation, when the dielectric is not totally filled up, what will be the capacitance? How to find out for this? So same as usual, C is equals to Q by V. Okay, and what is Q? Total surface charge density into the total area divided by potential. Now potential drop across V1, V2, V3. So what is V1, V2, V3? The potential drop between this is V1, between here is V2, between here is V3. Okay, so these three potentials. So this I can write sigma A divided by, we already know V is equals to E into D. D is the thickness. So if I want to find out V1, then the electric field, what will be the electric field here? Sigma by epsilon naught, because no dielectric is present. So sigma by epsilon naught into the thickness. What is the thickness? X plus. Now in the second case you have a dielectric. So what will the electric field? Sigma by K epsilon naught. Right? And what will be the thickness? It is your into T plus. Now you don't have dielectric in this region. Sigma by epsilon naught, and what is the thickness? D minus T minus X. Okay, so I hope this is clear. Now sigma can be cancelled out from everywhere. Here it is gone. So what is left out? C will be equal to how much? A divided by X by epsilon naught plus T by K epsilon naught plus 1 by epsilon naught into D minus T minus X. Okay, so what we can do is we can take the epsilon naught above. So epsilon naught A divided by it will be d minus t minus x. Then this will be plus x plus t by k. Okay, so my a plus x minus x is gone. So what will be left out for this? Epsilon naught a divided by d minus t plus t by k. So this is how you can find out the capacitance of this kind of arrangements. Now from this thing, from this one, it is quite clear. It is quite clear that uh, your capacitance in this case is independent of x. So what does it mean? It means wherever you place your dielectric, this is the value of x, no? So it is independent of x. You keep it here or you keep it towards more towards the right, you keep it more towards the left. So it has got nothing to do with the expression for capacitance. Okay, is it clear? Now moving to the next one. Suppose instead of one dielectric, there are two dielectrics present in this manner. Suppose there are two dielectrics of different thickness and of different dielectric constant are present. Okay. Now what will be, how can you write down its value? According, looking into the formula which we have derived, C will be equal to how much? Epsilon naught A divided by D. D is as usual, this is the distance between the two plates is D. So D minus T1 minus T2 plus T1 by K1 plus T2 by K2. Okay. So this is how you can write the formula. Right. Now instead of 2, suppose you have got n number of, so many are there. Then how will you do it? Then for n number of dielectrics, where your dielectric constant will be represented as your Kn and thickness will be represented Tn. Then what will be the capacitance then? Epsilon naught A divided by D minus summation. Okay. So how many Tn's are there? Tnth plus summation Tnth divided by Knth. So like this you can do it. Okay. Now there are few things which are to be noteworthy for this case. The first note let us write. So if large number of dielectrics, if large number of dielectrics are there, then C will be equal to how much? Epsilon naught A divided by D, just the expansion of this one, minus T1 minus T2 dot 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 minus Tn plus T1 by K1 dot 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 plus Tn by Kn. Okay. Now the second note we can take, that if your T is equals to D, if T is equals to D, and we'll consider this equation here. This equation will consider, in this equation, if D is equals to T, right, then this T and this minus T, they will be cancelled out. Okay. So what will be left out? Let's see. If T equals to D, then C will be equal to epsilon naught Ka by D. That this means what? Here the dielectric is fully filled between the parallel plates, Okay. So if you put it in the equation, you'll get this, and this you already know, already you have calculated. So whatever you have found out, the result which you have found out is going to be correct. Okay. This is a cross check. Second thing, the third important one, in case we place a conductor, suppose in case of a dielectric, we place a conductor. In case of conductor, we have calculated what is the value of K. K is equals to infinity here. Then what will be C then? We know C is equals to epsilon naught A divided by D minus T plus T by K. We know this value, right? So in case of K, I'll put it infinity. So something by infinity is 0. So what will be the value of C? C will be epsilon naught A divided by D minus T. Okay. So this is an important relation, that instead of your dielectric, if you keep a conductor, in which case, in which diagram? In this diagram. In this diagram, if you are going to place a conductor in place of the dielectric, then what will be the capacitance? Okay. Now, in the fourth one, which is very, very important to understand, that we will take two assumptions here. for your T, for T is equals to D. That means what? The dielectric is totally filled with between the two parallel plates and K is infinity. So what does it mean? That means in between two parallel plate capacitors you have totally filled with a conductor. Okay. So what will be the capacitance? Let us see that. In this case your C is equals to epsilon naught A divided by D minus it was written T, but here T is equal to D, so I have to write minus D plus D by infinity. Okay, this is the case. So plus T minus T is gone. Something by infinity is 0. So C is equals to epsilon naught A by 0 and something by 0. So C turns out to be infinity. Okay, what does it mean? C turns to be infinity. What does it mean? It means that the capacitor is one of the plates of the capacitor is grounded, is earthed. Then you're going to get what? Then you'll get your C is equals to infinity. So this is an important case which you should follow. Okay. So these are the 4 different notes which you should take care of. Okay. Now let us get into some typical problems which comes in the exams. Okay. So the first question I have written for you. You are given with a parallel plate capacitor and it is introduced with a dielectric. The thickness of the dielectric is 2 centimeter and it is placed 2 centimeter away from the positive charge plate and 2 centimeter away from the negative charge plate. Okay, and this is your dielectric. Okay, now the potential which is given, one side is 0 volt, other one is 10 volt. So what is asking you? It is asking you to draw a potential versus X curve and your electric field versus X curve. You have to draw that. Okay. So now we'll see the potential. It is quite evident the potential decreases. Okay, decreases as we move from positive plate to the negative plate because of the value 10 volt and 0 volt it is given. So we can make this statement. And we know electric field is minus dV by dx. Okay, and this dV by dx is what? It is the slope of which curve? V and x curve. So this implies my slope is equals to minus E. Okay, right. Then next case, let me divide into 3 different regions. This is region 1, this is region 2 and this is region 3. 3 different regions, let me assume. Now what is the electric field in 3 different regions? The electric field is constant in region 1, 2 and 3. Okay, what is its value? Electric field in region 1 is how much? Sigma by epsilon naught, which is constant. In second region it is sigma by k epsilon naught, that is also constant. In the third one sigma by epsilon naught. So what we observe is your electric field is going to be constant throughout. Okay, and different regions. So let us first plot this one. So if we have a E versus X graph, and here it is 2 centimeter, 4 centimeter, 6 centimeter, because all of them are 2, 2, 2. Okay, the first value is in this region the electric field is constant. So this is sigma by epsilon naught, and in the third region also it is same. So this will be the sigma by epsilon naught. Now in this region what will be? It will be exactly half. Why? It is sigma by k epsilon naught and k value is 2. So this becomes half of this one. So this is the graph E versus X graph. Okay. After plotting E versus X graph, you have to plot for V versus X graph. Okay. Now while plotting this graph, it is very important to take care that your electric you have to take the slope of this, right? Now when you try to draw this graph, you will see this graph, you have to draw it in this manner. So this is my dotted line which will make me the angle theta 1, suppose, right? And in this case also you have to do it in this manner. You have to do it in this manner. This will be your theta 1. Both of them will be having same slope. Okay, but in case of this one you will have a different slope. Here the slope will decrease theta 2. This will be something else, theta 2, right? So let me redraw this one again, and here it will be in this manner. This one will be theta 1. Okay, so your theta 1 is greater than theta 2 in this case. Both of them will have the same slopes, and this one will be a stiffer one. So we can say here that the electric field has decreased. Okay, so the drop will be less. So the drop is less. You can see in second region the drop or the slope of the curve is less. Okay, so this is how you can plot your V versus X graph. Is it clear? Now moving to the next question. In this question, you are given with a symmetric dielectrics. So what do you mean by symmetric dielectric? Symmetric dielectric means they are having different dielectric constant K1, K2, K3, but dimension wise they are same. Okay, area, then the thickness of all the dielectrics, they are the same. Okay, now we have to draw an equivalent capacitance diagram for this one, right? So it will be how? It will be like this, right? Capacitors in series C1, C2, C3. All three of them are in series. Now what you have to do? You have to find out the individual capacitance C1, C2, C3. So what is C1? You will find out C1 is how much? Epsilon naught A. It is K1 divided by D by 3. Okay. So why it is D by 3? Because they are symmetric dielectrics. So D by 3, D by 3, D by 3. So this comes out to be D, total D. Okay. And area is remaining same for all of them. And K1 because first dielectric is K1, value is K1. So this will give me 3 epsilon naught A K1 divided by D, right? Then what will be my C2? C2 will be same 3 epsilon naught A K2 divided by D. And what will be my C3? It will be 3 epsilon naught A K3 divided by D. Okay. Now we have to find out C equivalent also. We know for when the capacitors are in series, 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. So now what I will do is, we'll put the values of C1, C2, C3. So it comes out to be D divided by 3 epsilon naught A K1 plus D divided by 3 epsilon naught A K2 plus D divided by 3 epsilon naught A K3. Okay. So D by 3 epsilon naught A you can take common. So you'll have 1 by K1 plus 1 by K2 plus 1 by K3. Okay. So if you want to find out the C equivalent, you have to inverse is. So 3 epsilon naught A divided by D, and this will be K1, K2, K3. Once you have taken the LCM, it will be like this. K2, K3 plus K1, K3 plus K1, K2. Okay. So this is the value of C equivalent. Now there might be a small twist in the question which is given to you. The arrangement might be in this manner. Here also the symmetric dielectrics, three different dielectrics are taken. Thickness between the plates is D. You have to find out C1, C2, C3 and C equivalent. But here if you draw the equivalent of this in form of capacitors, they will be in parallel. They will be in parallel in this manner. Okay, right? So this is C1, C2 and C3. Here the capacitors are in parallel. Followed. Now what will be C1, C2, C3? Let us do that. Your C1 will be equal to epsilon naught. Area is how much? A by 3 into K1 divided by D. Area is A by 3 because this is A by 3, A by 3 and A by 3, that turns out to be A. If C1 is this, C2 will be how much? C2 will be your epsilon naught A by 3 K2 by D. C3 will be how much? Epsilon naught A by 3 K3 by D. Okay. Then how will you find out the C equivalent? For parallel, it is C1 plus C2 plus C3. Okay. So C equivalent will be your, you can take common epsilon naught A divided by 3D, you can take common. It will be K1 plus K2 plus K3. Okay. So this is how you can solve different problems related to dielectric. These are the few types of questions which come in the exam. So kindly like the video, share the video, do subscribe my channel, as well as If you have got any queries, you can email me in the mail ID which is given below. Finally, thank you for your kind patience.